looking at a rotation problem, these rotation problems that we're going to kind of start this unit with are very similar to motion problems from unit 2, 3, 4 from the beginning of the year when we had our original best friend. But if we had some sort of motion problem where we wanted to see like the acceleration of an object as it's spinning faster. So maybe you have one of those little toys that spins around and lights up, or maybe you're just looking at a fan that's spinning faster. Maybe you're looking at a car wheel rotating down the road and speeding up as it's rolling. Or maybe a ball is rolling away from you. Whatever. You could think of so many different things of something speeding up. I could take this foxtail here and start spinning it slowly and then speed it up faster and faster. There's so many different options you can do here. But let's say we have some rotating object that has some initial angular velocity of 4 radians per second. Okay, remember, radians themselves aren't a true physical unit, but it gives us an idea of how much something is rotating. And then let's just say that at some time later, it's speeded up. Then it has a final velocity of 10 radians per second. And let's just say it takes 2 seconds to speed it up. What is the acceleration, angularly, the angular acceleration that this object experiences in doing so? So if we wanted to kind of solve this problem, if this was an old problem earlier in the year where we had an initial and a final velocity and some amount of time that it happened in, you would just take the change in velocity divided by the amount of time, and that's an acceleration. And nothing changes in this problem here. In order to find the acceleration, the angular acceleration, alpha, all we're doing is we are taking the change in angular velocity divided by some amount of time. It's just a change in velocity in an amount of time. Remember that delta is always a final minus initial, so this is going to be our 10 radians per second minus 4 radians per second, all divided by the time, 2 seconds. When we work that out, in this example, these are really nice numbers that we have. 10 minus 4 is 6 divided by 2. That gives us radians per second, or 3 radians per second squared. Okay, so just like old units of acceleration, but we have a new meter, so to speak. It is the radian. It is just how much of an angle you've gone through. So they're just old equations that we're using and bringing back. But this time we're doing this in this kind of rotational sense. How much faster are you rotating? That's kind of the idea there. Where we just have some initial quantities, we kind of look to our best friend for an equation, and we get something there. So that wasn't that crazy of a problem. We're just looking at our best friend for an equation, plugging in our known values, and getting ourselves a little answer. So that's a pretty simple, straightforward motion problem with just angular quantities. And you work those the exact same ways we always have this entire year. You just need to use kind of different symbols for it. Okay? So with that, that problem's finished.